Hey friends, my name is C and you're watching MakesItEasy, and welcome back to a new video for A-level mathematics. And today we have 2.2 for the sums of squares and cubes for the questions video. And we'll get started with the first question, but before we get into it, don't forget to leave a like, subscribe, and ring the notification bell so that on any future videos. And we'll get started with the first question, and these questions are from exercise 3b from the Core Peer 1 textbook, so you can check it out. So here's number 1, evaluate. We have 4 sum expressions right here which are split into 4 different columns. So the first one is the sum of r squared from r equals 1 to r equals 4. So we know that the sum of r squared, which I'll write it out, the general sum of r squared from r equals 1 to n is equal to 1 over 6n times n plus 1 times 2n plus 1, like so. So therefore we can see that in this case n is equal to 4. So we just have to substitute n by 4 in all these cases. So therefore the sum of r squared from r equals 1 to 4 is equal to 1 over 6 times 4 plus 1 times 2 times 4 plus 1, plus 1. And this will get us, let me just put into my calculator, the sum of x squared or r squared from r equals 1 to r equals 4, and that's equal to 30, like so. And question 2 is basically the same for the sum of r squared from r equals 1 to r equals 40. So in this case we just have to substitute n by 40, because n is basically the upper limit of the sum, so 40, and this will be equal to 1 over 6 times 40 times 41 times 2 times 40 is 80, 80 plus 1, 81. And this will get us, let me just put into my calculator, sum of r squared from r equals 1 to r equals 40, and that gets us 22,140. 22140, like so. And for the sum for question E, or the third part, the sum of r cubed from r equals 1 to 100. So in this case we have the sum of cubes, not sum of squares. And we know that the general sum of cubes formula is the sum of r cubed from r equals 1 to n is equal to 1 over 4 n squared n plus 1 squared, like so. So therefore in this case this r, which is the upper limit, is equal to 100. So 100. Therefore the expression will be equal to, let me just write it down here because there's some more space on top, 1 over 4 times 100 squared times 101, because this is 100 plus 1 squared. And this will get us a large number, which I'll type into my calculator right now. So the sum of r cubed from r equals 1 to r equals 100, and that gets us 25,502,000. It's a huge number, I'll just write it out. 25502 and 500, like so. It's a huge number. And for the last part, the sum of r cubed from r equals 100 to r equals 200. So in this case, we have to split this into 2 different sums, because in all the previous sums, the lower limit is r equals 1, and the sum formulas work for when r equals 1 for the lower limit. Therefore, we have to split this into 2 sums, where the lower limit is 1. So the sum of r cubed from r equals 100 to 200 is equal to the sum of r cubed from r equals 1 to 200, because it's always the same as the first upper limit, minus the sum of r cubed from r equals 1 to 99. Because the upper limit for the second sum is basically the lower limit of the original sum minus 1. So 100 minus 1 is 99. So therefore this is equal to 1 over 4 n squared is 200 squared, and n plus 1 squared is 201 squared, minus 1 over 4 times 99 squared times 100 squared. And that gets us an answer of, let me just put into my calculator. So the sum of r squared from r equals 100 to 200, and that gets us 379,507,500, like so. It's a huge number as well. And when we deal with sum of cubes and squares, and specifically for the cubes, you will get a huge number, as you can see in these cases. And we have question 2, or question 4 in this case. Let me just rub this out. So show that the sum of r cubed from r equals n plus 1 to 3n is equal to n squared times 4n plus 1 times 5n plus 2. So you first have to just write the whole expression out, the original expression. So question 4a, the sum of r cubed, from r equals n plus 1 to 3n is equal to, which is split into two different sums. It's equal to the sum of r cubed from r equals 1 to 3n minus the sum of r cubed from r equals 1 to n. N. Because this is basically the same as this, and this is basically this. And this is basically this lower limit minus 1. And now we just basically substitute the formula in, where it's basically 1 over 4 n squared times n plus 1 squared. So 1 over 4, n squared, n is 3n, so 3n, and 3n plus 1 squared, minus the same 1 over 4, n squared, and in this case it's just n, so n squared, n plus 1 squared. So we can see that we just prove that this equals this expression right here. So we can see that there's an n squared out here. That means that we have to factorize an n squared. And we can see that what's common in those two cases, in these two expressions, we can see that there's a 1 over 4 and 1 over 4 and n squared as well. So we can actually just factorize a 1 over 4 n squared. But we can notice that in the question, there's no 1 over 4. That means that after we factorize 1 over 4 n squared and we simplify the expression, there will be a 4 that we need to factorize in order to cancel out the 1 over 4. So let me just do it now. So it will be 1 over 4 n squared times 3, in this case it's 3 squared, so it just be 9, times 3n plus 1 squared, minus, we've taken out the 1 over 4 n squared, so it's just n plus 1 squared, like so. So now we basically just simplify the whole expression. So it'll be 1 over 4, it will be 1 over 4, and 1 over 4, 1 over 4 n squared, times 9 times expand this to get 9 n squared, 9n squared plus 6n plus 1 minus n squared plus 2n plus 1, plus 1, like so. And now we just basically expand the bracket, which I'll do it up here, is equal to 1 over 4 n squared times by 9 times 9 is 81, so 81 n squared, and what's next? 9 times 6 is 54, so 54 n, and 9 times 1 is plus 9, and just minus the expression where it's minus n squared minus 2n minus 1, and now we just simplify the whole thing, 1 over 4 n squared, and the bracket is 81 n squared minus n squared, which is 80 n squared, and let me just zoom in, 80 n squared, and let me just wrap this out, so 80 n squared, and for the n is 54n minus 52n, minus 2n, which is equal to 52n, and here 9 minus 1 is equal to plus 8, so plus 8. And now we can see that we can factorize a 4 out of those, right? So this 80 divided by 4, it will be equal to 20, and divide by 4, and divide by 4 like so. And this will get us n squared, and 80 divided by 4, as mentioned, is equal to 20. So 20n squared. And 52 divided by 4 is equal to 13, so plus 13, and plus 2, like so. And therefore now we're really close. We just have to factorize the whole thing. So we can factorize it by just considering two brackets. So it would be 1 of 5n, or 4n, we can just match this one right here. So one will be 4n, and one will be 5n, and two numbers that times together to get 2, and it will be plus 2 and plus 1, and just fit it in the right orientation, or in the right bracket to get 4n plus 1, and 4n plus 2, and that's the answer, like so. And for part B here, hence evaluate the sum of r cubed from r equals 11 to 30. So what we would do normally is that we would split this into two different sum expressions because the bottom isn't 1. But in this case, it'll be a bit different because we're given this expression right here, and we need to use this expression to relate to this expression right here. So let me just write it out. Part B, the sum of r cubed from r equals n plus 1 to 3n. We need to somehow relate this expression. We need to somehow relate this expression to this expression right here. So we can see that the original expression, the bottom is n plus 1, right? And we can see how this can be split into 10 plus 1, which basically matches the form, right? And in this case, this number is it's n, because n right here. And we can see that the top fits 3n, right? Because 3 times 10 is 3n. So therefore, this matches the form. Therefore, it will be equal to the sum of r cubed from r equals 10 plus 1 to 30. And therefore, in this case, n equals 10, right? So we can substitute 10 into the equation. So 10 squared times 4 times 10 plus 1 times 4 times 10 plus 2. And this will be equal to, let me just type into my calculator, 10 squared times 40 plus 1 times 50 plus 2. Let me just bracket this, 50 plus 2. And this gets us 213,200. So 213,200, like so. And the next question, show that the sum of r plus 2 times r plus 5 from r equals 1 to n is equal to this expression right here. So what we do first is that we have to first expand this bracket. So let me just expand it right here. So 7a, the sum of r equals sum of r plus 2, r plus 5 from r equals 1 to n, and this equals to the sum of r squared plus 7r plus 10, and this equals from r equals 1 to n, r equals plus 10. And we have to split this into 3 different sums. So the first sum is just r squared from r equals 1 to n, plus the second one, which is 7 times the sum of r from r equals 1 to n, plus the third one is 10 times the sum of 1s, right? Sum of 1, r equals 1, and n, right? So now we have to basically express each of these in their own expression. So the expression for the sum of squares is 1 over 6n times n plus 1 times 2n plus 1. So 1 over 6n, in this case is just n, so n plus 1 and 2n plus 1. And in the second one, the sum of natural numbers is 1 over 2 n plus 1. So 1 over 2 n plus 1. But don't forget that we have to times this expression by 7. So instead of 1 over 2, it will be 7 over 2, because it's basically 7 times 1 over 2. 7 over 2. And the last one is just 10n, because this right here is basically equal to n, right? So now we have to simplify it into this expression right here. So we can see that we have to end everything with 1 over 3 at the front. And there's no 1 over 3 at the front right now. So we just have to factorize a number that is common to all three expressions. So we can basically just factorize 1 over 6, right? Because 1 over 6 divided by 1 over 6 is equal to 1. And 7 over 2, if we take out 1 over 6, it will be 21. And this will be 60. And you can see that there's an n at the front, so we have to take out an n as well. So I'll first take out 1 over 6n. 1 over 6n. Bracket, it will be bracket n plus 1. And 2n minus 1. And for the second expression, it will be 7 over 2 divided by 1 over 6, which is equal to 21 times n plus 1. And the last one will just be 60, like so. And therefore, we can just simplify the whole thing. 1 over 6n times 2n squared plus 3n plus 1 plus 21n plus 21 plus 60, close bracket. And now we just have to simplify the whole thing. Let me just draw it up here. It's equal to 1 over 6n times 2n squared plus 3n plus 21n is 24n. 24n plus 60 plus 21 plus 1, which is equal to 82, like so. Oops, 82. And now we can notice that we have to factorize a 2 from everything, because this is 1 over 3, and 2 times 1 over 6 equals 1 over 3. So it would be 1 over 3 n, and factorize a 2 from this gets us n squared. Let me just use a new color. So 1 over 3 n and n squared, and 24 divided by 2 is 12, n plus 41, and that's the answer. QED. And question part 2. Hence, calculate the sum of r plus 2 times r plus 5 from r equals 10 to 50. So let me just call this expression as, let's say, x, right? So the sum of, or let's say r, or like, sorry, x, yeah, x will be good, from r equals 10 to 50. This will be equal to the sum of x from r equals 1 to 50 minus the sum of x from r equals 1 to 9. And now we just have to substitute n by 50 for this one right here, and n by 9 in this case. So it'll be 1 over 6 times by 50 times 2 times 50 blah 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 blah, which I will run it all out, like so, minus 1 over 6 times 9 times 2 times blah blah blah, and I will run it all out because it will take too much space. And I'm just put into my calculator the sum of of x plus 2, or r plus 2, and r plus 5 from r equals 10 to r equals 50 using the previous equation gets us 51,660. So 51,660, and that's the answer. And lastly, we have this question. Show that the sum of r times r plus 3 squared from r equals 1 to n is equal to 1 over 4 and blah blah blah, where a, b, and c are integers to be found. So we first have to expand this expression right here. So it will be equal to 12a will be equal to the sum of, let me just write out, r times, let me just expand it right now, expand it. So it will be r squared plus 6r plus 9. And this will be equal to the sum of r cubed plus 6r squared plus 9r from r equals 1 to n. And let me just split into 3 different sums. So it will be the sum of r cubed from r equals 1 to n plus 6 times the sum of r squared from r equals 1 to n plus 9 times the sum of r from r equals 1 to n. And now we have to just express it in their own expressions. So the first one will be 1 over 4 n squared plus times n plus 1 squared plus 6 over 6, because it's 6 times 1 over 6, n plus 1, and 2n plus 1, and 2n plus 1, and I have no more space. I have some space, it's fine. So plus 9 over 2n n plus 1. So you can see that there's a 1 over 4 in the front, so we can factorize 1 over 4 out of everything. But 1 over 4, let me just see if we can factorize 1 over 4 out of everything, and we can. So let's just factorize 1 over 4n. So it'll be 1 over 4, 1 over 4 n, and this will be left with n times n plus 1 squared, n plus 1 squared. And the second one, 6 over 6 is just 1. So 1 divided by 1 over 4 will be 4. So 4n plus 1, 2n plus 1. And 9 over 2 divided by 1 over 4 will get us 18 plus 18 n plus 1, like so. And now just factorize, just simplify everything. 1 over 4n times n squared plus 2n plus 1 plus 4 times 2n squared plus 3n plus 1 plus 18n plus 18, and simplify it, it will get us 1 over 4n times n cubed plus 2n squared plus n plus 8n squared plus 12n plus 4 plus 18n plus 18, which is a really long expression. So now we just have to simplify everything. It'll be 1 over 4n times n cubed plus, let's cancel out. Now the sum of n squares would be 2n squared plus 8n squared, which is 10n squared. Now the sum of n will be 18n plus 12n, which is 30n, plus n, which is 31n. And now the sum of like normal, it will be 4 times 18, right? Which is equal to 22. Like so. And now we just have to factorize, factorize the whole thing. So we can't factorize this straight away because this will get us one real root and two complex roots. Therefore, we can do algebraic division, right? So let me just do some divisions here, which is a long question. So the n cubed plus 10n squared plus 31n plus 22, divide that by n plus 1, right? N plus 1. So let's just divide it now. It'll be n squared, so n cubed plus n squared minus, okay, that's 9n squared plus 31n. So it'll be plus 9n squared plus 9n minus 31 minus 9 gets us 22. So 22n plus 22. It'll be plus 22, 22n plus 22, and remainder of 0. That means the final expression is equal to 1 over 4n times n plus 1 times n squared plus 9n plus 20. Actually, no, let me just put into a new color because it will be easier to spot the answer. So it will equal to 1 over 4n times n plus 1 times n squared plus 9n plus 22, and that's the final, plus 22, and that's the final answer. Let me just remove this, plus 22, like so. And part B, hence evaluate this expression right here. So let me just rub the algebraic division out, and let me just draw part B here. So we have what this expression is equal to, we have this one right here. So we just have to split this into two different sum formulas. So the sum of, let's call it x from r equals 10 to 20 is equal to the sum of x from r equals 1 to 20 minus the sum of x from r equals 1 to 9. And basically in this case, n is equal to 20, so n equals 20. And in this case, n equals 9, so n equals 9 in all these. So I'll just type into my calculator to save some space and to save some time. So the sum of r times r plus 3 squared from r equals 10 to 20 is equal to 59,070. So 59,070. And that's the final answer. And that's it for this video for 3.2 for the sums of squares and cubes for the questions video. And I hope you'll find it useful and helpful, and if you did, please leave a like and subscribe and ring the notification bell so that you don't miss out on any future videos. And if you have any questions or comments regarding my channel or my YouTube or my Instagram, you can leave them down below and I'll reply to them. And check out my social media in the description, for example LinkedIn or YouTube or Instagram. And if you need any learning resources or any teaching resources, you can check out my website in the description, or you can type it out in your browser at www.MakesItEasy.com. And I hope you'll find it useful and helpful, and this will be the last video for the chapter or the topic 3 for series. And in our next video, we'll move on to 4.1 for the roots of quadratic equation under the new chapter of topic 4, which is roots of polynomials, which will be fun and interesting. But anyways, I hope you'll find it useful and helpful, and I'll see you all in the next video. But until then, stay safe and happy learning.